So this is our third day factoring, and today we'll learn one more new kind of factoring. Well, let's talk about the ones we've done before. The first thing when we factor we're always going to try is look to see if there's a GCF, greatest common factor. The second thing we're going to try is look to see if it'll factor into two binomials. And then the third thing we learned was factor by grouping. And today we're going to talk about some special cases. For instance, a special case that might look something like this. X squared minus 25. I want to try the two things that multiply together that would give me this. So if you'll notice, this is a binomial. It doesn't have a middle term. So it looks something like this if it did have a middle term. So when I'm factoring, I know that I'm going to have an x and an x, and I know that the two numbers that I put here and here have to multiply to give me 25. So it's either 1 and 25 or 5 and 5. But these two numbers have to add together to give me that middle number. So if you think about it, it's going to have to be 5 and 5. And one of them is going to have to be positive and one of them is going to have to be negative, because this gives me 5x and this gives, whoops, I said positive negative. That gives me negative 5x and that gives me positive 5x, which gives me 0. And a positive times a negative gives me a negative 25. Let's do another one like that. X squared plus 0x minus 49. So this is going to be x and x, and then I have to think of two numbers that would multiply to give me 49, but when I add or subtract them I get 0. Anytime you're going to get 0, this number has to be the same in both spots. So the number that you multiply by itself to get 49 is 7. And in order for them to cancel out, one of them has to be positive and one of them has to be negative. This is a special case. If you notice, this term is always something squared. Happened on both problems. This last number is also something squared. And then each one of them had a minus in front of that number that's squared. So let's come up with one that's like that. Let's do x squared minus 16. Some of you may recognize that one from the pretest. So this one is going to factor as a special case because this is something squared. The thing you square is x. This is something squared. The thing you square is 4. So I would get plus 4 and minus 4. If you can't think of if this number is a perfect square, you can find the square root button on your calculator and put that number under it and it'll tell you if it's a perfect square. So what about this one? 25x squared minus 81. So I have to decide, is this a special case? Is this something squared and is this something squared? And it is. This just happens to be the square of 5x. And this just happens to be the square of 9. So when I factor, I'm going to have 5x and 5x and plus 9 and minus 9. So that's the special case. Notice I have a square and a square. And what's the sign in between? Subtract. So that's why this one is the special case called the difference of two squares. Because we have a square that we're subtracting. So typically when I'm in class now, I'll have a kid that'll say, hey, does this have to be minus? Could it be the sum of two squares? Or does that have to be minus? Well, if you think about the fact that that's a plus, if I factored it, it would have to be x plus 4 and x plus 4. But when I check my terms, the outside and the inside, it would not give me 0 here. So this only works when it's the difference. It has to be a subtraction problem before it will factor this way.